So take the number 8, for example. We want to find what we call the factors of 8. Basically, a factor of a number, or later on we'll talk about algebraic expressions, same thing. Factor is basically what can I divide into this number evenly? What numbers can divide into 8 evenly? All right? So you've got to start thinking about division, and you can alternatively think about it in terms of multiplication. Another way to think of it is the same thing as what division is. What numbers can I multiply by something to give me 8? Okay? So we can think of it two different ways. So let's just think about both of them. The number 1. Can the number 1 be divided into 8? Of course it can, because 8 divided by 1 gives you 8. And when I say can it be divided in, I'm talking about can it go in a whole number of times with no decimals and no fractions. So that number can go in. The number 2, can that be divided into 8? Yes, it can, because 2 times 4 is 8, right? The number 3, can the number 3 go into 8, divide in evenly? No, it can't. 3 times something, nothing works to give you 8. So 3 is not a factor. But the number 4 is a factor because 4 times 2 is 8. The number 5 is not a factor because 5 doesn't divide into 8 evenly. The number 6 is not a factor because 6 times nothing works to give me 8. The number 7 is not a factor because I can't divide him into 8 evenly. But the number 8 is a factor because 8 times 1 is 8. Or another way to look at it is 8 can divide into 8 evenly. So there's two ways to think about factors, and both of them are fine. You can think of them as a list of numbers that divide evenly into here. That works great. But a better useful way to think about it, because as we get into algebraic expressions, it's going to be a little easier to think of factors as numbers that you can multiply by something to give me 8, which is exactly what the definition of division really is. So they're the same exact definition. You see, 1 times 8 is 8, 2 times 4 is 8, 4 times 2 is 8, 8 times 1 is 8. So all of these are factors because they can each be multiplied by something to give me 8. There are no other numbers that work, and we've kind of gone over that. So let's just go and crank through a bunch of examples here. What are the factors of the number 10? So let me tell you one more thing. This whole list, these are called the factors of the number 8. All right? Now let's go back to the number 10. What are the factors of the number 10? Well, I'll tell you right now, the number 1 is always a factor because in this case, 1 times 10 gives me 10. And then I just march up, going through number by number, and I just see what else can be divided evenly. The number 2 is a factor of 10 because 2 times 5 is 10. The number 3 is not a factor because it doesn't divide evenly. The number 4 is not a factor. The number 5 is a factor because why? 5 can divide into 10 evenly. The number 6, 7, 8, and 9, none of those divide into 10 evenly, so they're not factors. The number 10 is always a factor. So again, look at this list and make sure you understand. 1 times 10 is 10, so it's a factor. 2 times 5 is 10, so it's a factor. 5 times 2 is 10, is a factor. 10 times 1 is 10, so it's a factor. The other thing I want to point out, the number 1 is always a factor of whole numbers like this, and the number itself, in this case, the highest number we always get to is always the number itself. It's always going to be in the list. So those two are always going to be factors, the number 1 and the number itself. The intermediate numbers you need to think about in terms of division or multiplication, however is easier for you to think about it. All right, so let's go and talk about the number 15. Let's list the factors of the number 15. Well, I told you number 1 is always a factor, so you can put that there. Then you ask yourself, is 2 a factor? 2 cannot divide evenly into 15, so it's not a factor, but 3 can, so that's a factor. 4 is not a factor. It cannot divide into 15. But 5 is a factor because 5 can divide evenly. Now 6, 7, 8, 9, 10, 11, 12, and 13. None of those numbers can divide evenly, and 14. None of them can divide evenly into the number 15, so they're not factors. The next one that comes on this list is the number 15. So we only have 4 factors here. So again, look at the list, make sure you understand. 1 times 15 is 15, 3 times 5 is 15, 5 times 3 is 15, 15 times 1 is 15. So the factors you have are a list of numbers such that you can multiply them by something to give me the number that you're investigating. Now let's look at an interesting example. What about the number 37? Let's list the factors here. Well, the number 1 is a factor, it divides, or you can think of it as 1 times 37 gives you 37. Now here's the thing, you start cranking through numbers 2, 3, 4, 5, 6, 7, 8, 9, you keep going up. Nothing divides evenly into 37 until you get to the number 37. So some oddball numbers like this only have, 2 factors. You're always going to have the number 1 and the number itself as factors, but there's really nothing else in the middle that divides evenly into 37, so those are the only factors that exist for 37. Now let's look at the number 30. This number has lots of factors. You can probably think of lots of numbers off the top of your head that divide in, but if you're going to write a list of factors, you need to start at the number 1 and go from there. So 1's a factor, and you should be asking yourself, can this number divide in? Can this number divide in? 2 can divide in. 3 can divide in. 4 cannot divide in. 4 times nothing can give me 30, right? But 5 can divide in. 6 can divide in. 10 can divide in. 15 can divide in. And 30 can divide in. Now, I know I'm kind of going fast here because I already know the answer. I've already solved the problem. But the way you would do it is you just go through every number in the list, everything, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, all the way to 30, looking for factors. And you're just looking for numbers that divide evenly in here. And these are the only ones that are there because 1 times 30 is 30, 2 times 15 is 30, 3 times 10 is 30, 5 times 6 is 30, 6 times 5 is 30, 10 times 3 is 30, 15 times 2 is 30, and 30 times 1 is 30. I'm telling you to think of it in terms of multiplication as a list of numbers that can be multiplied by something to give me that, because that's going to be the easier way to think of it when we talk about algebraic expressions later on. So that's kind of where I'm going with that. And then finally, let's do a bigger number, 56. You're going to find that the larger the number, generally, the more factors you're going to have. The number 1's a factor. 2 is a factor. Why? Because 2 times 28 actually gives you 56. The number 4 is a factor because 4 times 14 is a factor. Now, I understand that you probably have to use a calculator or at least a separate sheet of paper to figure these out quickly. 5 and 6 are not factors. They don't divide in. But 7 is a factor because 7 can be multiplied by 8 to give you 56. 8's a factor because you can multiply that by 7 to give you 56. And then you crank up 9, 10, 11, 12, 13. None of those can divide evenly. But the number 14 can, and it's 14 times 4 gives you 56. And then you keep going up, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. The next number that actually goes in here is 28, and that's going to be multiplied by 2. And then the last number, you continue on into the 30s, into the 40s. The only other number you find that divides evenly is the number itself, 56. So again, the number 1 and the number itself are always in the list. Also, notice there's kind of a mirror image here. If you kind of think of a mirror being right here, you have 7 times 8 and 8 times 7. So the two numbers that multiply together to give you 56 are going to be factors. You have 4 times 14 and 14 times 4. You have 2 times 28 and 28 times 2. So anytime you find a number, whatever it's multiplied by to give you 56 is also going to be a factor. It'll have to show up in the list down the way. Now again, with large numbers like this, it's easier to use a calculator to figure out all the factors, but you know that's the way you just kind of have to deal with it. All right, now we'll do the last one, the number 100. You probably think there's a million factors of 100, but really there's not that many. 1 can go into 100, 2 can go into 100, 4 can go into 100, 5 can go into 100. But then you start skipping numbers because numbers like 6, 7, 8, and 9, they don't really divide evenly into 100, but 10 does. And then you keep cranking through. The next one you hit is 20 that can go in, and then 25 can go in evenly, and then 50 can go in evenly, and then 100, of course, can go in evenly. And that makes sense because if you look, like, there's a huge gap between 25 and 50, but if you think about it, like the number 36, 37, 38, none of those numbers divide evenly into the number 100. So these are the list of factors. 1 times 100, 2 times 50, 4 times 25, 5 times 20, 10 times 10, 20 times 5, 25 times 4, 50 times 2, 100 times 1. And these are the list of factors. So I know it's a little bit weird to talk about all of these numbers in an algebra class, but it's important that you understand what a factor is, because in probably 3 sections from now, I'm going to ask you to factor x squared, or I'm going to ask you to factor 59x cubed times y. And you're going to be like, what? So if I give you all that stuff now, before, if you don't know what a factor is, and you're going to be confused. So now you know, a factor is just a list of things so that I can multiply them by something to give me the number that I'm after. And if you prefer to think of it in terms of division, yes, each of these numbers can divide evenly into their to give you the number. Make sure you understand the concept of factoring, and we're going to continue talking about factoring in the next section.
Learn anything at mathandscience.com.